You may have noticed that we call the sine, cosine, and tangent ratios the primary trigonometric ratios, and that is because there are actually secondary trigonometric ratios, and that's what this video is going to talk about. We are actually going to solve equations that use the secondary trig ratios. The first secondary trig ratio we will look at is cosecant, CSC for short. So the cosecant of theta is actually just equal to 1 over sine theta. So that means the cosecant ratio of an angle is the reciprocal of the sine ratio of that angle. And if you remember going back to the right angle triangle, the sine ratio is opposite over hypotenuse. So what we can say here is that the cosecant ratio is 1 over the opposite over hypotenuse. And again, here we have this fraction in the denominator, so we are going to change that and write that as cosecant theta equals 1. You can think of it as divided by opposite over hypotenuse. And then when we divide by a fraction, we take the reciprocal. So that's hypotenuse over opposite. 1 times hypotenuse over opposite simplifies to just hypotenuse over opposite. So the cosecant ratio is hypotenuse over opposites. So you would take the hypotenuse length and you would divide it by the opposite length. So if you were given the information in a triangle and you were trying to find the cosecant of the angle, you can just take the hypotenuse and put it over the opposite. If you were given the sine ratio and asked to find the cosecant ratio, you could just take the reciprocal of the sine ratio. So secant, SEC for short, is the reciprocal of the cos ratio. We know that the cos of an angle, the cosine ratio of an angle, is the adjacent over the hypotenuse. So the reciprocal of that for secant is the hypotenuse over the adjacent. And finally, the cotangent ratio is the reciprocal of the tangent ratio. We know the tangent ratio is the opposite over the adjacent. So the reciprocal for the cotangent ratio is just the adjacent over the opposite. So you are expected to remember the names for these ratios. These ones are not on the calculator like the primary trig ratios are. So one thing that might help you remember which secondary trig ratio goes with the primary trig ratio is that in the cosecant and sine and secant and cos, one has a C and then the other one has an S. So the cosecant goes with sine, secant goes with cos, and then in the tangent and cotangent, they both have a T. It's the only ratios that have a T in it, and they kind of sound the same. So now let's take a look at solving 3 secondary trig equations. The steps are very much similar to solving primary trig equations. We just have to deal with a secondary ratio and change it to a primary ratio. Before we begin, we must notice that the question specifies that we want our answers for theta to lie between 90 degrees and 360 degrees. So any solutions outside of that interval, we will not count in our final answer. So in 1a, we are finding all of the angles in this interval between 90 and 360 degrees, where when we take the secant of that angle, we get this negative ratio. So remember that secant is the hypotenuse over the adjacent. So I will just change this to a fraction. So it's negative 4.134, which is the hypotenuse, and the adjacent is 1. So because we are given the adjacent and the hypotenuse, we now can find the cos ratio, which we're more comfortable working with because it's a primary trigonometric ratio. So that is the adjacent. So the adjacent to that angle is 1, and over the hypotenuse, 4.134. Because the secant ratio is negative, the cosecant is negative as well. And you can keep it just somewhere on the fraction. I like to keep my negative more with the numerator, but if you want to prefer to keep it with the denominator because it was on the negative 4.134, that's fine. As long as somewhere in that fraction you have a negative, you're fine. And remember, the negative just tells you which quadrants your solutions lie. So now we can just put this into our calculator. -1 divided by 4.134. And we get that the cos theta is negative 0.2419. So I'm going to find the related angle, so theta r, and I'm going to take the inverse, again, of only the positive ratio. So put in the positive number, and we get that the related angle is 76 degrees. So now we have a unit circle here. We should identify where our solutions are. Because the cos ratio is negative, we know that we will have solutions in the S quadrant and the T quadrant because cos is positive in A and C. So wherever cos is positive, that is where secant is positive. So we have negative solutions in S and T, so 76 degrees is not a solution. But the related angle of 76 degrees will help us find the solutions. So the first one is 76 degrees less than 180, and the second solution is 76 degrees more than 180. So 180 minus 76 is 104. 180 plus 76 is 256. Both of those angles lie within the interval that was specified in the question between 90 and 360. So therefore, we can just state that our solutions are theta equals 104 degrees and 256 degrees. So that means if you were to substitute in either of these angles into cos, you will get a ratio of negative 0.2419. But then to find the ratio for the secant of those angles, you would then say 1 divided by negative 0.249, and you would get negative 4.134. Your calculators will not give you the secant ratio, so you would have to go to the cos ratio and then take the reciprocal to find out the value of the secant ratio. In question B, we want to find the angle such that the cosecant of the angle gives the ratio of 1.414. So the cosecant is the reciprocal of sine. So I'm going to write sine theta equals 1.414. So again, I'm taking the reciprocal of the cosecant ratio, and then I'm going to use my calculator to figure out what that is as a decimal, and I get 0.707. Find the related angle by taking the inverse of that decimal number, 0.707, and the related angle is 45 degrees about. Because the ratio for cosecant is positive, the ratio for sine is positive. So we have solutions in A where all ratios are positive, and in S between 90 and 180 where the sine ratios are positive. So therefore, this 45 degrees is a solution. And then I only need to find a second angle. So this 45 degrees. So to find the obtuse angle, it's 180 minus 45. So the second solution would be 180 minus 45 degrees, which is 135 degrees. So if my interval said all the solutions between 0 and 360, both of these would be a solution. But because we restricted the interval between 90 and 360, this 45 is actually not going to be one of the solutions I list in my final answer. So therefore, my solution is theta is simply 135 degrees. And one last example, cotangent of the angle has a negative ratio. I added in this negative of 0.577. The reciprocal of cotangent is tangent. So I'm going to write that as a reciprocal, 1 over negative 0.577, and then use my calculator to find out what that is as a decimal. It's negative 1.733. So now I'm going to use my calculator to find the reference angle, Again, I'm only going to put in the positive ratio into my calculator to find that acute reference angle. So that is around 60 degrees. Because the tan ratio is negative, the solutions are going to be in S and C. The solutions are not going to be in A because all the ratios are positive in A, and not in T because only the tan ratios are positive in T. So that leaves S where tan is negative and C where tan is negative. The 60 degrees is therefore not a solution because that is acute. It lies in the A section, so there's no answer here. But we are going to use that 60 degrees to find the other two solutions. So the first one is 180 take away 60 to get to that first solution, and the second solution is 360 take away 60 to get to that second solution. So 180 degrees minus 60 is 120, and 360 take away 60 is 300. Both of those lie in the interval between 90 and 360, so they are both solutions. So the solutions for theta are 120 degrees and 300 degrees. Just an important reminder of when finding the second solution at 300 degrees, many students will work from the 270, the y-axis, and add 60. You're always working from the x-axis. So it's going to be 360 take away 60. So how many degrees does it take to get to the x-axis? On the left side, it's 180, and on the right side, it's 360. So you should always be adding or subtracting your related angles from 180 or from 360 or from 0 degrees.